Hmm. Hello students, welcome to our channel. Today I am going to discuss electrostat. So first of all, we will see what is the meaning of electrostat. The word electro means charge and stat means at rest. That is charge at rest. So in this chapter we will discuss about the properties of the charges which is at rest. So first of all we will see the charge. What are the basic properties of charge? So first of all we will do the properties of charge. Properties of charge. So charges have the few properties which characterize the charge. So following are the important properties. The first important properties is the types of charge. That is, charges are of two types, positive and negative. So first property is charge is of two types. First, positive charge, and second, negative charge. Second important properties of charge is that charge is conserved. That is, the charge can neither be created nor be destroyed. Okay. So that is the total charge of an isolated system is always conserved. Okay. The total charge of an isolated system is always conserved. The charge cannot be created and cannot be destroyed. The charge is conserved. Next, very important property, that is charge is quantized. Charge is quantized. So it is important point. Quantization means कि any charge can be expressed as an integral multiple of an smallest unit of charge, which is known as a quantum of charge, smallest quantum of charge. That is, mathematically, this property can be written mathematically as Q is equals to plus minus Ne, where N may be any integer 1, 2, 3 and so on, and E is equals to electronic charge. E is equals to, its value is 1.6 into 10 to the power minus 19 Coulomb. So this means कि a charge we can only have a charge which is the integral multiple of E. We can have a charge equals to 10 electron, 20 electron, or positive also, plus minus. Q is equals to plus minus Ne. We cannot have 4.5, a charge equals to 4.5 electronic unit charge, 5.5 electronic charge. So that is the quantization of charge. It is something like nowadays the smallest quantum of money is 1 rupees. Nowadays the 1 rupees denomination is the smallest unit of money. So we can have or we can give someone 4 rupees, 5 rupees, 6 rupees and 10, 100 whatever. But we cannot, if someone asks give me 10.5 rupees, 10 rupees, 10.5, we cannot. Means कि money in this case is quantized in terms of 1 rupees. 1 rupees is the smallest quantum. In a similar manner, charge is also quantized in terms of electronic charge. Understand? So this is the quantization of charge. Next, charges can be added or subtracted. Charges can be added or subtracted like a scalar. Like a scalar. That is 4 Coulomb plus 2 Coulomb is equals to 6 Coulomb, or even if one is 4 Coulomb minus 2 Coulomb, then it is 2 Coulomb. So charges can be added or subtracted like a scalar. Okay. Next, invariance of charge. Invariance of charge. Invariance means कि the value, the magnitude of a charged particle is fixed irrelative to the speed of movement. It means कि if a charged particle even moving with a very high speed or even accelerated, then also its value do not change, unlike the mass and length. Mass, length and time according to relativistic theory. So there is no effect of relativity on value of charge. So this property is known as invariance of charge. The charge remain fixed. Charge remain fixed with the speed or with the motion. However is the acceleration and whatever with the speed of movement. That is the invariance. So these are few important properties of the charge. Now we will discuss a very important law in the electrostat, which is known as Coulomb's law. So now we will discuss Coulomb's law. Okay. Coulomb's law. According to this law, the two charged particles, say Q1 and say Q2, placed at a distance r apart, exerts a force of electrostatic attraction or repulsion. Two charged particles, say Q1 and Q2, placed at a separation r, exerts an electrostatic force of attraction or repulsion, which is directly proportional to the product of charge and inversely proportional to the square of distance. So this is the one of basic law of the electrostat. So suppose कि the nature of charge is say at opposite. So they will attract each other. And from the Newton's third law, these are the action and reaction pair, so this force must be equal and opposite. So the two will apply equal and opposite force on each other. So according to the Coulomb's law, this force is directly proportional to the product of charge and inversely proportional to the square of distance. If we will try to put the equality sign, that if we wish to find the exact force, that how much exactly these are applying these charges applying the force on each other, means if we want to know the exact value of F, then we have to put a proportionality constant which is experimentally determined. So finally the net force is equals to Q1 Q2 by 4 pi epsilon naught R square, where Q1 and Q2 are the charge, epsilon naught is equals to, epsilon naught is the absolute permittivity of free space. Epsilon naught is the absolute permittivity of free space, and R is equals to separation between the charge. Separation between the charge. The value of the constant 1 by 4 pi epsilon naught is equals to 9 into 10 to the power 9 Newton meter square per Coulomb square. So we can remember this value. This is the standard result. The value of proportionality is 9 into 10 to the power 9 Newton meter square per Coulomb square. Now one important point, the value of this constant, the value of this constant depends upon the medium between charge. The value of this constant depends upon the medium between charge. That is, if the medium changes between the charges, the value of this constant will change. This value is for the air medium or free space, vacuum or air. We can use this as the proportionality constant K. But in case, suppose the charged particle is dipped in some other medium, for example water or oil or somewhere else, then this value will no longer be valid, and we have to introduce another factor. What is that? We will see. The value of this constant depends upon the medium between charge. If a medium having relative permeability ER, if a medium having relative permeability ER is used, then the value of constant is K is equals to 1 by 4 pi epsilon naught epsilon r. Or K is equals to 1 by 4 pi simply epsilon r square, where epsilon is equals to epsilon naught into epsilon r. Epsilon is read as the absolute or total permittivity of that medium, intervening medium in which the charge is placed. Now, why this value changes? This is because of the polarization of the medium due to the electric field produced by the charge, original charge. The charge particle produces an electric field, and the presence of that electric field, the medium gets polarized little bit, and a reverse field generates, which decreases the original force. So the force between the charged particle will always be lesser in any medium as compared to the free space or air, because ER is always positive and more than 1. So here we can also notice one point. ER is always greater than equals to 1. So the net force between any two charge So the net force between two charge in any medium will be less than that of vacuum. This is an important point. As ER is always greater than equals to 1, so the net force between two charges in any medium will be less than that of vacuum. So the maximum force can be applied in vacuum, and if we will change the medium, the force will little bit decreased, and the exactly it will be epsilon r time less. The force will be reduced by epsilon r times. Suppose it is inserted in oil, and let the permittivity ER, the relative permittivity of that oil is 10. For example, say 10. Then the force will reduce 10 times as compared to that of air. Okay. Now we will do some problem. So is it clear? This is the basic of Coulomb's law. So that basically it provides the magnitude of force, the magnitude of force acting between two charged particles. So now I am going to discuss one question to find the distance and value of a charged particle between the two charged particles such that the system could be in equilibrium. See, suppose there is a charge Q1 and here it is a charge Q2. Okay, fine, and the separation between them is L. Okay. Now let K charges are of same type. So I take case 1. Charges are of same type. Then we have to find the location and the value of a third charge which should be placed such that the system remains in equilibrium. We have to find the location of a third charge which must be placed somewhere along this line of Q1, Q2 such that the system of three charges could be in equilibrium. How we will find? Let a charge Q is placed at a distance at a distance x from Q1. So obviously this distance will be L minus x and the total distance will become L. Okay. So we have to find this location and the value of small q also as well. How to find? See, the first thing, when the charges are of similar type, then the location will lie between the charge, that is on the line joining Q1 and Q2, in between Q1 and Q2. That location must be somewhere in between Q1 and Q2. So the value of x in this case, directly I write x is equals to root under Q1 upon root under Q2 plus root under Q1 plus root under Q2 into L. So this will be the position. And here one thing must be noticed, that this distance x is from Q1, which is appearing in numerator. Okay. If you will place here Q2, then the distance you will get the distance from Q2. This distance is from Q1. If I will put here Q2, then it will be distance from Q2. You will get the distance from Q2, that is L minus x you will get. Okay. And the value of this small q in this case, value of the small q in this case will be, it will be Q1 into Q2 upon Q1 plus Q2 plus 2 into root under Q1. So this is the value of charge that must be placed. So there will be a unique charge and a unique position which will result the equilibrium of the system of this two charge Q1 and Q2. And the position is this x from Q1 and the charge value of charge is this Q. I use little big font. Maybe it is not visible. Okay. Case 2. Case 2. Case 2. If the charges are opposite type, if charges are of opposite type or opposite nature, if charges are of opposite nature, that is one is positive and one is negative. Say this is your plus Q1 and this is my minus Q2. Then in this case, the position will not lie between Q1 and Q2. It will be outside the Q1 and Q2, and there is two sides. It is possible that this side or this side. So the location, your location must be near the smaller charge. Say if Q1 mod is less than Q2 mod, then it will be here. Suppose somewhere here I got. This is your L, the separation between two charge, and let here is the position where small q should be placed to make it in equilibrium, to result the equilibrium, and let this distance is x. Please note that the distance is taken from the smaller charge. It must be lying toward the smaller charge. So if Q1 mod is less than Q2 mod, then it will be on Q1 side, and if suppose Q2 is less than Q1, then it will be that side. So simply I write the formula here: x is equals to